Hello, I'm Michel Com from Blocksmith, and we provide data privacy and security for SMBs and organizations. We want to make data 100% secure. Let me explain how do we achieve that. We'll have a glimpse of our magic. We do fine-grained, standard, state-of-the-art encryption, so we can evolve with the algorithm as the cybersecurity standards evolve. Fine-grained because 80% of the data, corporate data, is unstructured. So you protect at file level, at email levels, and it provides protection when you don't use the documents, but also when you have the document in use, because you only decrypt the buffer that is in memory for the line of the document that you are accessing. So you don't expose, you have very, very little surface to expose your data in clear text. It's just the buffer that you are working on. All the rest is protected. We use public key infrastructure, but we don't have the requirement of having a private key store anywhere. So public key infrastructure without private key is resistance to attack where you steal, criminals fish around for keys and then try to open the locks, all the locks that they found with those keys. We enforce strong password so that makes them resistant to brute force and still being able to have easy password to memorize. We use multi-factor authentication in a frictionless way to protect us from phishing. The most important point of our system is that we use no credential or hash stored on any of our servers. No record of that. That means no way of conducting a crack algorithm or a brute force attack or even having a quantum computer problems setting up a quantum computer to crack our system. Public key infrastructure. All secrets and private keys are derived from the password, and that's in real time. Because we have a password that we combine with multi-factors, we have enough entropy for generating a strong keys, and we don't store it anywhere. No hash, no password, no no etc password file, no user directory. For the server, the user is anonymous. We don't know the difference between a legitimate user and a criminal one. That means your data is protected all the time, no matter who you are showing up at the server. So we won't give away your data either or because everybody is anonymous. What we give is we give the key for you to use with the data. So either you are the authentic one, we give you the right key, or you are a criminal and we give you a key that decrypts some data but does not give you the right documents. So it's like you have the authentication side is done on the client side, and you have false positive or false negative, either if you are a criminal or if you are a legitimate user. No, like I said, no credential records. That means it's impossible to conduct an attack, even with a quantum computer, because we cannot build the problem to be solved. Strong password. Most of password systems are using the same old 7-bit character, ASCII characters for password because of mainly the keyboards that we have. We have today a wide range of characters, 32-bit Unicode characters, emojis, and so on. So why not using them with passwords so that we make attacks, cracking tools, totally inefficient at cracking them? Today, it takes few seconds to crack a 14 characters password. And with machine learning, cracking is even faster because AI is learning how to find the password that the human being is capable of memorizing. So to scope the universe of possible password, when you know your target user, it's even much smaller. Real-time check are possible when you have introduced a layer between the user and the login authentication services. So we can check if the password is in the database. We can check if it's in a dictionary. We can enforce policy for strong password. That's why we can guarantee 340 bits entropy. And all that seamlessly. We can advise the user about security tip, about any type of policy that's required on the password level. So I mean, we make easy to remember password strong enough for generating keys that any type of brute force would never guess. And we can personalize the keyboard, we can personalize the password alphabet if we are on a device or on a desktop. We can have all those options possible. Phishing remains the main weak point because if you rely on something you know, then all the social engineering can be deployed to get access to that knowledge. How do we protect that? We have hidden MFA. So it's like when you enter a lobby of a corporation, you just show up your ID, you show your business card, and you sign in a timing sheet. We do the same. You drop a virtual business card with a virtual sticker, an MFA sticker. An MFA sticker is a sticker like this one that has a code, a key that is encrypted, so that it won't be able to be used if you don't have all the other factors. And we can increment the level of complexity, the number of factors based on a behavioral analysis. Something you are, we monitor the way the user types the password. We do FFTs analysis. We can conduct a machine learning about so that the user is profiled and we can recognize between a legitimate user that knows his password versus a user that doesn't know the password or a user that is under stress. And with all those factors combined, we can provide exponential security because if we have any doubt, we ask for an extra factors. But rather than adding them sequentially, we add them, we combine them. And that's why we have order magnitude more secure system. That allows us the guarantee that we have multiple factors that allow us to generate one-time password without key. So you don't need, one-time password are the authenticator like the Google authenticator, where there is a need of a shared secret between the device and the server. You don't need that. So I mean, this secret cannot be stolen because it's generated on the fly. So we have a minimum of 3 factors: something you know, the password; something you have, the device; and something you are, your behavior. Or biometrics if you have a device that has biometrics. And liveness, basically. How do we achieve security on the database? It's totally different than unstructured data. Unstructured data are protected by encryption. Database is different because you have to process the data in real time. That means you have to have service accounts that are capable of decrypting data with a God key, meaning that if this key is stolen, it's open bar. Everything can be stolen, and that's to make it a very interesting target for criminals. So we shift the problem by, instead of having the data protected at rest and then putting the database in a vault behind walls, that once you get in, just doesn't protect any data anymore. So we use tokenization, but at the record level. Any data is replaced with a homomorphic data, the token, that has no link at all. Guarantees zero knowledge, zero data, silent token. And because of our algorithm, we cannot recover the data if you don't have the dynamically generated key that match the user. That allows us a tokenization that doesn't require a lookup table, doesn't require an index stored somewhere behind vault, because then you would just move the problem from protecting the database to protecting a vault or this table. And so for the logic, the token behaves exactly like the original data. So all API, all software will be functional, but the decoding of the token is done at the edge, where the key can be generated, because at the edge you have all the factors. On the server, we guarantee that you will always missing one or two factors. So I mean, if you steal the data by breaking in the server, or if you steal the data by breaking in the user device, you are missing factors for reversing the token. That's how we conduct high level of security. We provide tools to SMEs to protect their data, guarantee the privacy. And so you have a bunch of other tools that are very useful in a daily working environment that will make ransomware totally obsolete, pointless, where you don't fear exposure of your data anymore. Here you go. I'm Michel Kahn. I thank you for listening to my quick overview of what we're doing. And if you need more information, you can have my LinkedIn by scanning this QR code.